Okay, on this second video on Wednesday, January the 30th, we're going to show a few test points to verify that the board is working okay. This is the same setup we show in video number 1 where everything's working okay. And we're going to take a look at a couple of test points. The first one that I want to show is there should not be any phase loss. Therefore, the PL signal at J6 position 3, so Tony's going into J6 position 3, and we could take a look at the schematic, should be high. It's high, it's saying I don't have a phase loss, it's clear. If we were to bring in a phase loss condition, then that will drop to 0. But we notice the important thing here is that it's not changing, it's not flickering, it's solid. And do me a favor, Miguel, can you clear the 480? So now that we clear the 480, that signal is again solid low. That's one thing to check. Now, go ahead and bring it in for me. Now the next signal that I want to show is the N signal. So let's go now to J6 position 15. And you want to show where 15 is, Tony? From 11. We've got 11, 12, 13. So it's the top row. And in there, just to verify, this is something that I don't think you're gonna have a problem because you're getting the phasing from J2 post modules 4, 5, and 6. We have a positive sequence, that is, we're firing in the same sequence as the reference we have, and the end signal should be 0, should be low. That means positive logic. You're bringing in the A into the A input. You're bringing the B phase into the B input, the B input. Reference wise, phase reference wise, and the C into the C, and we're calling the A SCR, A plus A and minus A SCRs are in fact the plus and minus A SCRs, and the same thing with the B and C. The next signal that I want to show is test point number 1, and we'll notice that as SIG HI right now, it's 0. TP1 is maximum. It's approximately a little over 10 volts. So Tony, you want to go ahead and give me SIG HI? So as Tony is gradually increasing SIG HI, TP1 it's slowly, gradually coming down. So you're at 20, you want to bring it to 20, Tony?
Yeah.
All right, there we go. At 20, he's already at 0. And then as he starts decreasing SIG HI again, that it's going again, but you notice how smooth that is. The next signal that I want to show is test point 7. And look, here we see a pulse range, and I could probably open this up just so that we see that. And you have JU1 out, therefore you're seeing a single 120 degrees. And go ahead and start doing. Go ahead and increase SIG HI. And we notice that here the signal should stay solid no matter what we're doing. And this is just a matter of, go ahead, Tony. And of course, in order for us to look at all this, we would have to show it. But this is basically a signal that it's our signal that it's modulated to the clock. That's just to verify that everything is working there. And the very last signal, and this is an important one, it's test point 2. Here I'm going to change the setting. I decided to make it the last one. So I'm going to bring it back so that we can see it at about 5 milliseconds per division. And then I'm going to increase its amplitude. And I'm going to bring in set up there. And then probably there, I'm going to make my trader there. Alright, so this is a signal that it's a sawtooth waveform signal that has to be as uniform as possible. And then this is test point 2. It's if I were to bring this to my 0 to 5 volts, if I were to make this 5 volts exactly, and I could type it, I just want to get on the approximate. There we go. This is the 5 volts. This right here has to go through the 0, and you can see that it's riding over the 0 because it's biased at 5 volts. And let's go ahead and start changing SIG HI from 0 to 20. And the important thing to check here is that the board is well balanced. You notice that that's not, and here it's just a triggering function. Go ahead, Tony. But it's even when you go to null, you want to hit the null, Tony. You have as close as possible to a zero line, a zero signal at 5 volts. So go ahead, Tony. So at any time you have a uniform sawtooth waveform bias at 5 volts, so that when you look at that signal with a multimeter, the average, stop right there, Tony. The average will be 5 because this voltage being above will compensate with this voltage below 5 volts, and that will be as close as 5 volts. So these are the signals that I appreciate if you can verify that are operating okay with the board that you have or not, and then that will tell us what's probably wrong with the board. This is the end of this video.